49, and today we're going to be going over a project that I've been working on for the past while. I've been studying the virus of influenza, or most commonly known as the flu, and today I'd like you to take you and show you what it's all about and how we can prevent it. So here's our agenda. First, we'll be introducing ourselves to influenza, and then the biology of it and the structure, transmission, infection, how we can prevent it, and current research going on and possible future research. And then we'll end with some conclusions, some key insights, and recommendations. So, first, what is the flu? So, the flu comes from a family called Orthomyxoviridae. It's a family of RNA viruses, which includes the flu, and they have a segmented genome and they're very fast at mutating and reassorting, which is another way it can kind of change its code in order to be very elusive, which is one of the reasons why we have to get a flu shot every year. More onto that later. So it's a very serious public health challenge due to the fact that it's constantly evolving, constantly changing, and it's caused multiple epidemics. Most well-known one is the Spanish flu, killing millions, and yeah, it's one of the most prevalent diseases that we know of. And it's very important for us to know and understand how it works so we can learn to develop vaccines and protect ourselves from viruses like the flu and the flu itself. So, what's the biology of this thing? So, the flu is a negative strand RNA virus, which basically means that normally strands are DNA. RNA is a positive strand. Basically, the RNA is automatically able to be translated into its protein that it's meant for. RNA is the messenger between DNA. Some viruses are just only RNA, so they directly become um, proteins and building blocks in order to, replicate. So the influenza, what makes it so special is that it's a negative strand, and instead of directly being able to translate into proteins, it's actually able to translate. It has to translate one time into a positive strand, and then it translates one more time into a protein in which that can actually like build more influenza viruses and uh, harmful proteins that are contribute to infection. And it is a segmented genome allowing for multiple RNA strands to be replicated at the same time. And it also allows for those segments to be rearranged into different orders, creating practically new versions of the virus, which can be either more deadly or just as deadly or maybe less, but in most cases it's more deadly as it becomes a new thing in which more often than not your body wouldn't be ready for. And the name that we've given um, viruses like the flu's ability to constantly change how it is and constantly escape antibodies that we make for an entire year. It's called there's two types: antigenetic drift and antigenetic shift. So antigenic drift is the process where the antigens, which are surface molecules on a virus, that's basically like its identity marker. These antigens are slowly changing over time, which results in after a certain amount of time, usually 1 year, what the difference between the change that we had 1 year ago versus now makes a completely new looking virus, still the flu, but now your antibodies that your body may have gotten last year, it wouldn't work, which is why you would have to vaccinate again. Antigenic shift is the process where multiple strains of influenza interact and they can practically combine in a way that it creates a new strain of influenza which has completely different markers or markers that it inherited from one strain and the other, but making it to your body a different strain of virus, which is another way the influenza can evolve past your antibodies and your immune system. So onto the structure. Okay, so there's three main components that are very well documented. hemagglutinin, neuraminidase, and M2 protein channels. So hemagglutinin, we'll call that as HA, and neuraminidase as NA, and then M2 protein will just be M2. Okay, so hemagglutinin is what causes entry into host cells by binding to what is called sialic acid, which is on the surface of mostly the epithelial cells in your trachea. What that is basically the very surface cells in your throat where you breathe through. Okay, those are the cells that are often getting, touched by the air. That is where there's most celiac acid, in which hemagglutinin binds to, allowing for the virus to actually like attach to your throat, which is why most influenzas or whenever you catch the flu, you're feeling it mostly through your throat. And then neuraminidase, basically what that does is it kind of opens up your host cell and opens up the virus at the same time, allowing the virus to just basically open up into your own cell, allowing for the release of its, virions and stuff. And the M2 protein is basically an ion channel. What an ion channel is, it is a type of protein that brings ions, which are charged atoms. But when we mention ions in biology, most of the time we are referring to hydrogen ions or just protons. So what the M2 does is that it channels in channels in protons, which creates an acidic environment, which boosts the speed of enzymes which build the virus and replicate. So that's their roles. And the segmented genome not only allows for targeted change, but also, like I said earlier, it can reassort and leading to new variants. So how does this virus actually go from place to place? So first, it can spread through droplets and surfaces, or just droplets falling on surfaces. And basically, every time you talk, cough, or just any sort of motion that kind of opens your mouth and leaves out a gust of air, along with that air is going to be some very tiny drops of water. And when someone is sick, that water may be diluted with the virus, the flu. And through this, someone else can breathe those tiny water droplets, or they can touch them with their hands and allow the virus to enter through basically any like area where the virus can enter into your body. So your ears, your eyes, your nose, your mouth, those are all spots where sicknesses can enter, or viruses, can enter. That's one way. That's like the main way influenza really spreads. So once you are sick, like a certain contagious period where you are most contagious. That is specifically one day once you notice your symptoms. That is the day you are most contagious, and that is also the day that you should not risk interacting with anyone else in order to not get anyone else sick. And usually lasting for about 5 to 7 days, those symptoms. And after that time period, that's when you usually start feeling better, and that's when your body has successfully taken down the flu. So it's very good for us to understand how transmission works in order to implement controls measures against spreading the virus around. So the infection cycle, okay, we kind of went over this a bit earlier, but the infection cycle binds to host cell receptors, binds to the host cells with the hemagglutinin over here, and then it comes in through endocytosis, which is caused by the neuraminidase, and that allows it to release the viral RNA into the host cell. M2 ion channel is crucial for uncoding the viral genome and is essential for replicating due to the acidity it can bring into vesicles, which allow it to fast forward enzyme reactivity. And once inside a host cell, it basically hijacks how most viruses work is that they hijack your host cell and make your cells start working for the virus and start replicating the virus. And the flu does the same exact thing, where as your host cells start producing viral proteins for itself, and that's how it starts culminating. And then once multiple new viruses are done, they are ejected. Okay, so ways we can prevent this is with hygiene practices, so hand washing always and sanitizing if you can't wash your hands, always good to reduce transmission and communal settings, i.e., like when you're, out in public or in offices. There's lots of things that are shared use, like doorknobs, everyone's touching those, along with devices, multiple people might be using the same device, so it's always good to disinfect those like hot spots, I guess, for spreading in order to minimize transmission. Ventilation is important. We would want to decrease ventilation from someone who is sick. You would want to wear a mask in order to block possible um, sickness being let out to the world. And um, it's also, masks are a good way from also blocking other people's sickness to from getting to you. Example would be during COVID-19 when many people would everyone would have to wear masks in order to avoid getting sick. And yeah, just good ventilation inside of houses is also another good way in order to make sure the flu is not like lingering around in certain environments. By having good ventilation or air purifiers, you can minimize the amount of like viruses that might be like floating as single particles through the air. And of course, the end all be all, well, not really, but still very important, the flu shot. Make sure to take it every year. It's the most effective way to prevent the flu, because how a vaccine works is that it gives your body a non harmful version of a certain virus, in this case, a non harmful version of the flu. Your body will figure out that it is not meant to be in your body, and after killing it off, your body will create antibodies which remember the exact flu, so that way when you do get sick during the year from the certain type of flu, your body will already be able to find out that there is the flu. Anyways, there is this video from the World Health Organization on YouTube where we go over how to wash your hands. First, you want to wet your hands before applying soap. So first you want to like start rubbing your palms together, like a circular motion, and then after a bit of time, roughly like 10 to 15 seconds of doing that, you want to flip one of your hands and start, as you can see this motion right here, your fingers interlaced in between one another and going back and forth, making sure to get the gaps in between your fingers. You also want to basically, this movement is your fingers are interlocked kind of inside, and you're just rubbing through that area in order to make sure your fingers really get washed. After that, as you can see, you want to really like get your thumb in there and just start like going, just spinning it through your other hand in order to lather it up and also wash that well. Okay, from there, as you saw, you want to like put your hands in a certain way that it lets your fingertips reach out and start rubbing it through your palms in a circular motion in order to clean the tips and under your nails. And then once done, of course, you would rinse. Yeah, a little trick right there. Once you dry your hands, best with a towel. You can use the towel that you use to dry your hands by using those towels to turn off the tap in order to minimize um, getting your hands dirty again by touching the sink. Anyways, if you want to watch the video yourself, I'll put a link in the description. Thank you, World Health Organization, for giving us this video for um, us and many people to watch. Anyways, onwards. Um, Alright, so here's some current research and possible directions going on regarding the flu. So there's been a lot of, as of recent, there's been studies on how the flu exactly evolves and how we can create like a dynamic cure for the flu, which like in order to fight against its constant evolution. And we're also looking through other like antiviral treatments besides the flu shot, which directly attack the proteins that we mentioned earlier, the hemagglutinin and the neaminidase or the M2 proteins, because since they're so important, by turning off one of them, it can decrease infection and sickness by a lot. So that's one other avenue. And yeah, there's lots of research going out. It's pretty easy to find research. All you can do, you can just go up on Google or whatever search engine you'd like, search up flu research, and I'm sure you can find a lot of like really informative articles which tell you about current research or new research going on in the flu. And we're just trying to, build a constant understanding, a better understanding than the day before, in order so that we can find and hopefully in a future there's like a end all be all cure for the flu and other viruses that just completely eradicate it, but one can hope. So in conclusion, the flu is very complex, and it's very important for us to understand how the flu works along with many other viruses, and it's good to educate many people, as I'm doing here, and on how to prevent how like certain viruses work and what we can do to safeguard against it. And yeah, uh call to action, I guess. Now, um go to your community, start posting little awareness posts where like tell people to wash their hands every day, multiple times a day, or take your flu shot during flu seasons. Anyways, yeah. Here are all my sources. You can take a screenshot, look through all of them. I'll make sure to link them all down below. Anyways, yeah. Hope you guys learned something new today. If not, then I'm sure you'll have some critiques. Please put those in the comments if I said anything wrong. I'd like to fix that. Anyways, that's about it. Make sure to like, subscribe, and yeah, leave a comment. Anyways, yeah, that's about it. See ya.